let's go over my stirrup detail with wood. Sorry, moving around in the chair a little bit. You might be able to hear it on the mic. So this is I've already got it queued up. I've got 3 videos queued up. And I predicted the failure here in this one, and the others were interesting too. I look at the grain structure and I try to predict the failure. And looking at this grain structure, quickly what stood out was this knot. I did not have access to see the back side of it at this point. So I just saw this tight knot. Wood knot is really a tree branch that came through it. And remember how I showed you in other videos that tree branches get stirrups growing around them. And so there's a small swirl, and I can't tell the rest too much. Looks like right about here's the pattern. And remember that when this is loaded, the compressor side is the top and the tension side is the bottom. I look at the bottom like, wow, that's pretty, the grain's pretty well symmetrical. Except for right about here, it looks like another branch. Small knot there. Very tight. And, but here is where when I say the stirrups are significantly, it comes this direction, that branch came through, significantly large, and it keeps working its way up to here. So that sort of indicates that the branch was in this direction there. But then I have another branch here that stirrups went around, and what appears to be another branch. But it's kind of straight, so it's almost like it lost it pretty quick, and it almost went through it. But nevertheless, these dissect the material, the lumber, the stirrups. It's like having stirrups, and then they divert around and coming this way, and it's like a defect in the stirrup design, if you will, or with loading. And so when I look here, I see that the grain structure goes this way and comes up and disappears into space. So that means when this gets stressed, this is where it's going to want to break. See, the grain structure is captured by top and bottom here. Pretty evident. Captured by top and bottom here. And about here, it almost dips away. But over here, the grain structure comes and disappears. So right here is where I nailed this one. I said this is where it would begin in my theoretical model, not in my brain, not here. But here, because as it's stressing, it's going to want to pop off. And this one I nail, right? So let's go. I'm going to go frame by frame. There it is. And there it is popping up. Watch right here as it pops up. Not to be confused by that's where it fails. Now you could argue that, let me see, go back one. Right there. See the stress in the knot? Right here? Right there, just so you can see it happen before you get this failure down here. I'm going to cycle it a few more times. So you can see the grain are separating at that point. Well, you don't see it, but that's what's going on. The grain structure, the stirrups are breaking apart. They can't hold each other anymore. Remember, these are just one layer of glue on top of another layer of glue on top of another layer of glue. In fact, to prove that glue action, if you will, if I were to dry this out and keep drying it out, pulling out the moisture, I'd be able to pull this apart pretty easily, these different layers. You need so much moisture content for wood to behave in a structural capacity. Otherwise, you're going to really devalue it. So watch again. And there it is, right there. So there's the fiber. Well, there's a fiber there that's activated, if you will. Right there. And then there's the next one that goes across. So here it profiles across. And then it's gone. And then, all right, so just so you know, so then failure's here first. But then the moment changes to it's no longer there because it's not connecting. So if I have a cracked arm, it can't work. A fractured arm, if I break my bone fully fractured, right? Not a compound, not open like that, just fully fractured somehow. Well, it's not connected anymore. The top is not connected to the bottom. At this point, they're not connected. It bridges around it. In this case, it had a new, it took a new path. And this is the fracture it took. Now, they're going to show it she's saying it buckles over here. Well, before it buckles, before it push the material up, it breaks free. The machine confirmation bias is what's going on there. So then we come down, and now let's go back up. So first it breaks free, and then the buckle is because the machine kept pushing down and snow plowed it into the material. Watch. So first we just get a break. All right, so it's just a break. And then watch the top, the fibers get you see kind of white fibers. That's her snow plowing back against here. We can't see more. Now, from this point, where do you think it would fracture? You know, it's a new profiled beam you're looking at as we freeze it. So now the beam doesn't even count. It's that break I told you about. So this doesn't even count anymore. So somewhere maybe the forces go like this at a 45. Looks like good solid material there. But down here we have the new sizing is from here to here. This the new material that's really taking on the deflection. This is not transferring over here any longer. So our new material looks like this. And at the top of that new material, we have a stirrup on top trying to capture it. We got this huge knot, if you will, a tree branch. And we've got it, but it's surrounded pretty good and huge material with huge lumbering. So this is, if you're trying to look at it, and you're also loading at 2 points. They're loading here, well, 2 going up on the ends and 2 going here. So this is pressing down, that's pressing down, point loading. But now this is the new, you got to remove this from your mind. This doesn't exist. This exists to some degree, probably going like that. Is how I theoretically see it. So I have the break somewhere about here to about where the knot is, and lo and behold, I don't have it figured out yet. Lo and behold, it marries. Watch this. So, okay. Let's see if it'll let me. I have to look over here. Let me zoom out. I have to. Yeah, it is let me scrub. All right, so I'm going to take this up very slowly. Actually, I think it takes a lot more to, yeah. There we go. So I think it moved already. Let's take a bump back. Really? Let me make sure I can move. I gotta look at the seconds over here. And going backwards. There we go. Yeah, it's like 24 taps to get 1 second. 23 taps, whatever it might be in this video. I'm tapping. And let me zoom up a little bit. See, it's taking a moment already. So the more flexural is right about there. It's moving. I think I just seen something jump off on. Nope, it's just settling down. That's so now what's flexing is the new these fibers in here. So remember, the moisture content counts on this, how much it's going to stretch. So just because this 2x4, whatever it may be, 2x10, whatever dimension it is, they're not all going to behave the same. This behaves differently than the others. You can't extrapolate that. Each one is what I'm driving at. Each one of these is going to behave differently depending on the knot structure. And this will prove it because this is going to fail based on the knot structure. And here she comes. And so here's your new curve, if you will. As you can see it going down, the new curve is down here more so. Smaller section. This expanded further down because now it's buckling, it's snow plowing. So it pushed, and this actually gave us some feedback back to it. Looks like we got a crack. Part of that feedback of this point loading is now compressing inside our knot and pushing direct one-to-one down, creating a new tension location down here, and not mid-span between the two of them. Okay, I said not mid-span between the two of them. Let's go ahead. And remember, that's still released, so the machine, see it bounced around a bit. And let's go forward. Yeah, so this is kind of a... It's the frames per second. It's way, it's like a fan. You just missed it, but it fractured from here, separating from here, and you could see the ghosting of it way down there, and that's how it just moves so fast. But there's the fracture plane back to here, so it separated from here, worked its way down to here, lining up with this crack before it just it got ahead of the machine even, and then it just breaks free. So it was lined up with there, and then married down. Now I don't think they're gonna. Oh, she's gonna show the back side of it. Hold on. Yeah, there's the back side of it. That's that one that dissects and goes across, and what she calls buckling right here is just the snow plowing, the material shrinking, getting compressed together by these 2-point loads. And then look at your knot acting. Your tree branch is not. That's a play on words, isn't it? Act as a dissection. It act as a control joint inside this system. And it's high here, but low on the other side. And there's the small stirrups around it here that we couldn't see initially. I couldn't see it. So here it is here. And then it dissects the material going up. So you can imagine, if you look at the knot, if this knot is on that side, that's kind of a better thing than having it dissect your material going all the way diagonal like that. And that's why you see the teardrop shape is telling you which way the branch is going. So when you want to evaluate it, you can look at it and go, okay, this is around my midspan. I'm going to get a failure here first around this knot section, the larger knot. The larger stirrup section is going to create my failure. Let's go to the next piece of lumber. Now this one is interesting. This is a glue lamb. So this is, but you still see what I call stirrups, right? These are just stirrups. They go around a branch. So you got to look at my, I'll tie this one with the stirrup video. They're just nature stirrups. Look at them. And then in this pattern, the glue lamb they put together, there's the stirrups going the other way. And I did purposely key this up backwards and reverse for you just so you can see it. Here's the stirrups this way, and it splits right down the stirrups, buckling. And then here's the stirrups, partial stirrups. They cut the material this way. And then here are the stirrups pushed against their compressive plate. And you can see them shearing off each other there. Let's back that up by 5 seconds. And this is what it looks like. And okay, good. That's a good start. So as they're compressing this top plate and bottom plate, I think they're compressing together. Or maybe it's just I think they're compressing together. Maybe it's just the top one pressing down. I think the guy said they were together. It doesn't matter for me right now, because all I cared about was the stirrup detail. First I looked at it before these cracks, and I see a knot, okay? So that's interfering with my... In fact, the stirrups built around that knot to make it stronger. They always, wherever there's a branch, they build around it. So there's a branch, it built around it, the stirrups. And they're falsely called growth rings by a lot of people. They're stirrups to make the branch work in compression and tension all the way around, 360 degrees. These have been hodgepodge together. So this stirrup and this, they're not the same ones. The pattern, let me look at that. Damn, they sure look close. Yeah, they're the same ones. This one's just the grain is more fibrous here. Wait a minute, let me zoom in on that. Oh, it's probably how they cut it. All right, small, very, very small very small piece of a twig there that's got these huge stirrup developing around it. So this is the top of the branch, of top of a tree section there. And this one here is now, you don't even see it, but it works its way back. And these are stirrups, so they're surrounding, and this is the clean piece. So this might be, well, except for that inclusion here, whereas it was where the tree was growing, the stirrups were developing. Something was on there, got between the layers there. This one now is same thing, nice and tight. As you compress this, these things are, think of it as an arch being pushed out, and it wants to push it apart. Now, our last good stirrup on this one is right here. Follow it around, see it, and then they're no longer integral. So this is glued to this stirrup down here. Don't even count the glue yet. That means this could just shear off right here. This piece could just come off easy, and then this one too, also rather. As you come down here, same thing here. It stops. The last full stirrup is there, so this would be a weak piece here. The last full stirrup is this one, so these are all weak on the outside. I just grab it and pull it apart. On this one, this is pretty much all just junk. It's already got a hole in it. Hold on, let's back that up a little bit. So let's listen to it. Let's go back and hear what he states.
Loading diagram shows a compressive force evenly applied.
I can't turn it up. Yeah, he's showing two directions on that. Let's do that. See, they're going to do two directions on it. Well, they got the diagram. All right, so compressive forces are now being applied, and the first we get cracking here. No, we get stress. The first is at the bottom. I can't see behind this, but there's the knot, the dissection of it, and there is the beginning of the end. Let's follow it. There's another knot. Remember the knot? So it jumped from here to here. The stirrups held, but there are no stirrups at the very knot itself. So it wants to fail at the very knots. Now this is just compressing the fibers together, and they have to displace, and so they're starting to buckle out. But remember, that's the stirrups will want to hold as this compression is happening. It doesn't get compressed like this in nature. It gets deflected, and the compression and tension happens. This is just pure, just compressing on all of it excessively, and not in nature, because it wouldn't. Look at that thing compressed down. Now I think we just lost a piece of it here. Look at those fibers crush. Look at it crush. Let's back that up a bit. Look at these shrink down and press into the just right there. Right there, there's the crack, and that's our last good stirrup right there. And so it's still good, because these stirrups are still going to want to act strongly, and then this should theoretically fail first. Let's just take it from there. Okay, there we go. We're coming off, and there we go. We're coming off at our, where it looks like it's crossing there too, but we're going to come off this piece. Yeah, there it is. All right. And we're back here a little bit. Okay, now the new moment is this is the last good stirrup. Well, actually they're deflected. They're wavy. And it's sheared off. And let's look at it. And that one sheared off. Just looking at that one there. Okay. Let's back it up and look at the next one down. This one go. All right, so there's a knot. Beginning from the knot, last good stirrup is here, but that knot created a nice shear plane. So it was dense. So this one actually took it. This one actually didn't fail in compression. The one that's in the middle. Let's go backwards.
Compression forces are now being applied to the specimen.
I'm looking for this shrinkage here between there and here. Okay, there we go. So that's a larger stirrup. So you can see it can't stretch as much. It didn't. It's just larger, so it just fractured real fast. Tighter. There's the largest stirrups here, and the tightest stirrups are down here. Let's go here. And there they did. I mean, they've already separated. Remember, the rule is once it's broken, it's broken. Then you got to now look at the new connect, new moment, new point where it's taking up the load. That would be on the other side here, and these look like they bypass each other, so this would be continuous. So let's just stagger over. This doesn't look like it. It looks like they bypass each other. So the next point is here, and down to here, and transferring with the stirrup and glue capacity, grabbing it. But it's already bypassed, and so it's down to here. So it would be here. So the bypass should be in this little section here, with glue action holding here, like a little box stirrup idea around this fracture. And then we should watch the box fail. And now the box separated because it was in stirrup capacity. It couldn't hold. It fractured through the stirrup, through the box. Now our new box would be here. So come across, and that's continuous just with the stagger. And well, it's all I can't see behind this, but I would say it's down here. So it would be box stirrup up to here. And our stirrups are looking at this is wanting to burst the stirrup out, the new what's left behind. It looks like it would want to split it top and bottom right down the middle. There it goes. Alright, so it's already made it there. That's just another compressive moment. Let's see, coming down here.
Large blocks of wood separated.
There we go. So there's you see the last blocks of wood separated. It's following the stirrup line, as you see. And there's the stirrups breaking apart and shearing apart, and there's the rotation of it. Let's back it up. And let's look at it again.
You can see the wood cells starting to crush.
He said wood cells start to crush. He called them wood cells. They are the stirrups. And remember, the moisture content allows for it, and then there's the stirrups just fracturing. Let's get away from that one. I think I have another video for you right here, this last one on this one. This is an interesting one. It looks like a good clean stock, except for, clear stock, except for right here. Here's a large knot and stirrup detail out to there, so that must have been a huge branch. And this one also. And the rest looks like it's just straight, except for right here. Looks like the see the stirrup, the new stirrup develop around it. So now that would be a point, and I'm just going to tag through it, and you see it break right there. There is no 45 that made it. These crossed. I already did the 45s way up here. This failed right where the inclusion is, where I won't call it defect because it's nature, but you're loading this material and expecting it to have, and it compressed too, and you see the compression in it. See how this is up, and the one girl there in the other video called it buckling because she saw that there. It's water content inside here. It's compressing, and that's just displacing it, and you're seeing the fibers after being crushed. The moisture content after being crushed in the stirrups, those stirrups being crushed together. And then over here, this is the knot. And if you're loading if all this being equal over here and all this being equal over here, see how clear it is, and the parallelness of the lines. So that would be parallel reinforcement. Think of it that way. And even the thickness of them, the grain structure is equal. So think of this as rebar. And they laid it out in layers. So rebar is good, 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 good. And right here, all of a sudden, our rebar gets a little funky. The profile of the rebar comes down, goes up, comes down. So down here, all of a sudden, we just lose our rebar. No rebar at the bottom. It's just a big chunk of concrete, if you will. Our last piece of rebar is here. Our last piece of reinforcement. This doesn't even count as rebar because here's the rebar. They just sort of just grabbed a piece and threw it in the ground. See it? So here it is here, and as we go through it, oops, let's go back. Forget that stress strain curve stuff. You can see it fell right at. That's the best frame I can get you because it's framing. Oh no, wait a minute. Right there it is, the one with the materials are shattered out, and there it is right there, right at the knot, right where you can predict it. So I'm saying all your material, all your wood material is predictable. I'm also saying think of these the stirrups as stirrups, and now when you see the grain structure like this, think of these as rebar stirrups, as rebar, if you will. So they're stirrups because they're in the tree, and they're cut that way. But if it's loading this way, then look at it as loading this way as these are rebar. If you're going to turn it the other way and load it, look at it now as the stirrups, and you've dissected it, and you can imagine it would fracture easily and separate along all these planes now of rebar that you've got created tons of fracture points. And I would pick the middle largest one as the weakest one, the thickest one. So maybe this one if you turned it and compressed it, this one, or maybe this one, but not necessarily the center, because each one of these are going to want to buckle out. If I could turn this 180 degrees, you'd see what I mean. They want to buckle differently. This is one large piece with dissecting here. Think of it as chopping wood. If you were to chop this wood up and you wanted to break it into kindling, and I gave you a small section here, you would hit each one of these, right? And it would give you each split each one off. Same thing as you would load it. You would go which one would be stronger, which one would be weaker. So loading it, I would consider dissecting here, loading with a flat plate. And then this would be the largest, strongest piece, being it's one solid piece without any dissecting members. And here is where it would, if you were to load the entire piece, this piece here, right here where this steps up, if you were to compress it and turn it, vertically, not horizontally like this, this is where I think it would you would see it as a buckle, but this is where it would fracture. This is about the wood grain structure, and I did a video on this, and it's stirrups, nature stirrups. Let's see if it comes up. Nature's stirrups. Sorry about that. Spelling's a little different there with the fingers. This one. So I did... No, that's that one. It should be another one of these. Huh. So this is the grain structure that I did the video on this one. Hopefully it pulls up another one. In this video, we're going to be giving a shout out to everyone who's been donating. Really appreciate you. Love you. All right, so there's nature's stirrups right there. You load it down. A tree takes, tens of thousands of loads of pounds of tons of weight around the trunk. The main trunk is just a stirrup behind a stirrup behind a stirrup behind a stirrup, and there's the bark out there. They're just stirrups. So as you try to compress it down, it won't go out. If we would build this in concrete, we would just put stirrups on the outside and then concrete all in the middle, and that's it. But nature says, no, we'll do it in a bunch of stirrups. As we grow, we'll keep adding stirrups. And we know it holds tons, and it can sway all the directions. This is so much in equilibrium that based on its loading also, it builds it. It needs a tighter stirrup over here. Over here, it didn't need such a tighter stirrup. But nature's beautiful in that way, the way it did it. I think I have one more. Another beautiful stirrup one. Why do I have that on the mix? Let's place it. It says mix right here. See it? And so I show you a stirrup using this clamp. This is a stirrup. Yeah, you guys should come to this video here. And where's the other stirrup? I'm looking to the right here. This little playlist. Interesting, this playlist they made here. I didn't make this playlist. Okay, just says mixed. I show you that without a stirrup, the sand, you just push it down, displaces. And then I show you what happens if I put a stirrup. So yeah, that just displaces. And now what happens if I put I'll show you the trees and all, and that there's stirrups like this bungee. Okay. Where am I? And this is a very odd one there. And I show it right there at the trunk, at the sawing there. And this grain structure. And then, where is my... I'm scrubbing here. Let me scrub. And there it's drying out. And so now it's just fracturing because it was designed, this system, it's stirrup, but it needs moisture. You dry it too much and you've got yourself something that's going to fail easily. That's what I'm saying. It's a dynamic thing. Wood is. You have to keep moisture in it. You don't want to just dry out a house. There's one of the cutaways of it, the knots. Where are we? Oh, right. I do show it here. The steel. Oh, that's the root structure. I was working on something else. Here's a mini version of it, a branch. It is stirruped. It is all a stirrup system. Stirrups are the key to engineering. Without stirrups, you're just not paying attention to nature. It's all stirrup. I'm trying to get it to focus there. Maybe not. We're talking. Let's just go forward. This is what we use. Just a steel basket and the reinforcement straight to stop the bending action. But the stirrups keep it from bowing out, buckling. But nature does it this way though. Nature will line it all the way up, stirrup it all the way out, and imagine this is the glue between each stirrup, the concrete. They don't use a huge section of concrete. They use these stirrups. As the tree gets larger, every one of these is getting nurtured, going out. Let's see here. Trying to see what I'm scrubbing. Oh yeah, this is a piece of oak, I think, and it's a wild thing. Look at it. It's pretty. But it's got a lot of junk in it, doesn't it? It's really junk, but it's pretty. I cut it in two dimensions there, so don't get confused by that. That one's cut there, cut in that capacity, and then I lubricated it so you can see it. But they're the stirrups, nevertheless. They're the stirrups. And oak is a tight wood. Oak is tighter. It's going to be more dry. It burns differently, etc. Now, this is what I'm looking for. So this is now just that without the. So you can see I'm pushing it down, no stirrups, and you can see it displace all the soil. Now, that's shadow. Now I put a stirrup down there, a single stirrup. Put the brick at the same location. Let's just get it leveled off a little bit. Same location. I don't compact this. I'm not trying to stack the deck. I remove the sand from around the outside so you can see that, that it's how the forces are captured. Now put the brick in. We push down and you can see the stirrups capturing it. That's what the stirrups do. Pound on it. It's captured, of course. It can't go anywhere. This is it can only displace so much, and get rid of the voids in the air around it, etc. But back to that one, we'll displace. Adding in a video, yeah, I want to share this with someone. I want to get you guys to possibly join his channel. I'm going to share this with this person and see if I can work with him. Oh, I talk about 4x4s here, and there are the stirrups around it, and there are the defects. Yeah, this is a good video. It's a good video. How the stirrups are built around here, and this is would be where this would want to fail and check off. This piece here, you want to take it off. Well, wait a minute, it dried, and there it is, right through the branch. And let me just jump forward through a little bit. And it's full of those darn tree branches everywhere. See the stirrups around them, building stirrups around them. This is just junk. I don't like 2x4 timbers mostly. They need their moisture content to be a structural capacity. There's a little stirrup. All right, take care. Yes, Shadow. That Shadow speaking up. Time to feed her, I think. Bye.